Hi, everyone. Thank you so much for joining us today. So today we're going to talk about machine learning, necessity versus application. As we all know, there's a lot of hype around machine learning these days, but is it a necessity all the time, or are we doing it sometimes just because we feel obligated to? So today we're going to answer these questions by walking you through various use cases where machine learning wins and struggles. We're going to start our journey by giving you a brief introduction. We'll give you motivation behind our work and explain the use cases that we're planning to cover. Afterward, we share some interesting learnings and insights from our machine learning experiments. And then finally, we end our presentations by talking about the impact of our work and a few closing remarks. So let's start with the introduction. My name is Azin Asgarian, and I'm an applied research scientist at Georgian's R&D team. We also have Rohit Saha today with us, who is working on this project with us as an applied research scientist at Georgian. And we also have the pleasure of having Brian Ritz with us today, who is the Director of Data Science Solutions at the Spins and is leading our collaboration on the Spin side. So as I said, I'm an applied research scientist at Georgian's R&D team. In Georgian, we invest in the best growth stage AI companies like Spin by taking a data and AI-driven approach. And now you may ask, why does an investment company need an R&D team for, which is a very valid question. The short answer to that is for driving product differentiation. In Georgian's R&D team, we work with our portfolio companies to accelerate the adoption of differentiating technology trends like AI, trust, and conversational AI, because we believe that these can deliver competitive advantage. To do so, we collaborate with our companies in different shapes and forms. Sometimes we play advisory role. Sometimes, if the problem is well scoped and niche, we try to solve it in a hackathon, which can take from a few days to 1 or 2 weeks. And if the problems require more in-depth research and exploration, we run a deep engagement, which can take from a few months up to a year, like our current collaboration with the Spins team. And we try to share our work and research with the research community by creating reusable toolkits and publishing our research in the AI conferences and workshops. So if you're interested to learn more about our toolkits and research papers, please check out the QR code below this page. And with having said that, now I pass it to Brian to talk about Spin's mission and use cases.
Spins is a wellness-focused technology company that partners with brands and retailers across North America to drive the industry and world forward towards a more vibrant and sustainable future. For more than 20 years, we've been working with the industry, retail and CPG industry, to understand the insights and trends that underlie the data that we get. The trends can be anything from keto to organic to specialty pet recently making an emergence. We bring all this data together with investments in AI, cloud platform technology to really understand these trends, understand what's driving the trends, and deliver those insights to our clients and retail partners. Now, bringing all this together, we have a few key use cases for ML that I'd like to get into today. We've been collaborating with Georgian over the last 3 months on. As you can imagine, we work with over 600 retailers, and bringing all of that data together it's a big task. There's a big time task ahead of us to bring all the data together. We've been working on this for a long time, but as you can imagine, there's multiple formats, missing data, incomplete data, different representations of the same entity, whether it's a product or brand or store or retailer. We get outdated data, late delivery. These are all issues that we work through every single day to bring value to our clients. We bring all that into one industry-leading database that has simple, normalized format, that's complete, that powers all of our client-facing products with an audible data pipeline from retailer to the front end. So part of normalizing all this data and bringing it together into a coherent whole is really understanding what the retailers give us in our own language. Essentially, something that a retailer might give us is something like this on the left in the gray. The retailer might give us an item file. It has 1 row per item with UPC. UPC is Universal Product Code. It's kind of an industry standard for identifying products. It might have the retailer's indication of their brand. As you can see here, it's not really a brand. The retailer, we get dirty data like this all the time. They're just saying it's candy season. That's not really a brand. And then you might have a product description. We can use technology in our AI and ML algorithms, as you'll see in here in a minute, to extract usable attributes that we can then report on from this data. In this case, our use case number one, we need to understand what the pack count is of each item. So how many individually wrapped items come in a multi-pack? The first two items here, you see there's 6. And the last one, there's only going to be 1. Second use case we're going to go through here in the future of this presentation is identifying brand from the retailer's data. So retailer, a lot of them do have brand counts. Not everyone even sends us a brand column. And when they do, it's not always reliable, as you see here. Usually there is some indication or some correlation in the data between the item description and the brand though. So we can use all encoded brands that we've accumulated over the past 20 years to potentially train an algorithm or create an algorithm, as you'll see, to create brand directly from an item description or a retailer's version of the brand for you to see. There's a little hidden information you can see as well. The obvious, ML is all the hype. Well, this is nearly, you can kind of squint and see a brand entity resolution problem here. And machine learning is kind of the go-to solution for a lot of these problems across industries. We're seeing it not only in retail, which is Spence's industry, but banking, aerospace, healthcare, agriculture. ML, over the past 10 years, essentially has really emerged as a total enabler of new capabilities. And we see that in the startup space. We've seen, up to date, up to 2021, 78 AI unicorns with almost 50 billion in total funding here and over 200 billion in total valuation. And so ML is definitely a proven tool in the toolkit to solve a lot of these problems. It's tough though. ML and AI, it's hard. As you see here, 87% of machine learning projects never make it to production. And so we're working with Georgian. We don't want to be a part of that 80%. We want to be part of that 13% that goes to production and succeeds in delivering business value from our AI models. And I'm going to hand it over to Rohit here to illustrate how this partnership has done just that, essentially.
Thanks, Brian. Pack count and brand identification are two very interesting use cases since they fall on extreme ends of classification problems. As a starter, pack count contains 25 class labels. On the other hand, brand identification entails classifying around 86,000 labels. Let's take a look at pack count first. We begin with a simple rule-based system where, given a description, we identify certain patterns of words. If a pattern is identified, the number that precedes it is extracted. In this example, we identify the word pack to be relevant for the task, add it to a table, and extract the digit 6. We do this exercise of identifying patterns across several descriptions, and every time we find a new relevant pattern, we add it to the table. On testing this simple rule-based model, it achieved 79% accuracy. While performing error analysis, we noticed certain drawbacks with our rule-based model. We realized that there are several new patterns that are not accounted for in our table, and manually identifying these new patterns across thousands of samples is very time-consuming. Additionally, what happens when the description does not contain any pattern? To overcome these drawbacks, we asked ourselves if we can somehow automate the process of identifying and associating patterns with certain pack counts, and for descriptions that don't have a pattern, can we keep track of them? Turns out that an ML-based transformer model does exactly these things. We trained a transformer model and it was able to achieve 85% accuracy. This is an 8% improvement over the rule-based model. The pattern identification process has now been automated, and the model can also handle edge cases where the rule-based model failed to predict the right pack count. ML clearly wins in this use case. Now, let's take a look at the second use case of brand identification. Here, the task is to predict a brand out of almost 86,000 classes, given a description of a product. Right off the bat, this is a much more complicated problem than the previous use case. However, we still start off with a rule-based tree model. After assessing the data, we proposed prediction logic that includes a combination of creating lookup tables to map descriptions to brands using intelligent string matching algorithms and employing clever thresholding tricks on string matching scores. Using these ideas, a tree structure is created. At the first level, the tree applies a logic or a rule to segregate the initial set of data points into two subsets. As more rules are discovered, they're added to the tree to further segregate subsets of data points into even smaller subsets. This approach achieved a 77% accuracy, which is great given the number of classes we are dealing with. However, on error analysis, we noticed certain challenges with the data, such as multiple brands having the same description. This results in several false matches and causes the chosen thresholds to fail. Similar to the previous use case, we asked if an ML-based model can handle these challenges, following which we trained a language transformer. To our surprise, the transformer model did not fare well with an accuracy of 55%. The performance dropped by almost 29%, and we realized that several brands with lower number of samples are almost never classified correctly. On the other hand, our rule-based model is able to handle this challenge. ML clearly struggles in this scenario. So what are the takeaways from the two use cases? First, given any problem, always start with a simple algorithm. This could be a rule-based model or something as simple as logistic regression. Starting with a simple model eases the process of error analysis, the insights of which can be used to quickly iterate over model versions. Second, for use cases such as pack count, where the number of classes is limited, the classes are balanced, and a clean mapping exists between the input and output, ML-based models can provide a lot of value. Finally, for use cases such as brand identification, with large number of classes and severe data challenges, highly complex ML-based models might not perform better than a simple rule-based model. Now I'll hand it over to Brian.
Awesome, thanks. Yeah, so what's the impact? What's the upshot of this? We were able to automate account brand identification 20 to 49% of our products that are coming through our database. So what that translates to directly is less time and cost. Everyone we cannot automate is a person going in and creating this themselves. So we have less human annotation, which directly translates into less time, less cost. We can free up those people to do what they're best at, which is more of those really core spins, attributes that really take a lot of the expertise that they're trained in, is like brand position. Is this a natural product or is this a conventional product type of decision? Since this is automated further, we can onboard retailers faster. When they hand us a file, we can automatically take a chunk of that annotation out, and that directly translates, kind of goes with reduced time, reduces the time they have to wait to see their data in our software products. Lastly, this helps us differentiate and elevate our spins brand as really a leader in AI and ML. So the upshot is we thanks to partnership with Georgian and thanks to the great work by the Georgian team and my team as well, we were not part of the 87%. We were able to deliver these insights, deliver the business value to avoid being part of that 87% and really be a leader in delivering value from them all.
Awesome. Thank you so much, Brian and Rohit, for the great walkthrough. So now coming to the end of our presentation, I just wanted to give a huge shout out to our other team members from Georgian and Spins, without whom we couldn't reach any of these milestones. Thank you guys so much for your hard work. And thank you as well for listening to our talk. We have a lot of different open positions at the Spins and Georgian. So if you're interested, please check our career pages. And also, if you wanted to join our Georgian Paper Club, where we run monthly presentations and workshops on various aspects of machine learning, please fill out our registration form using the QR code on the screen. So with coming to the end of our presentation, we would like to open the stage for questions if there is any.